So, somewhere near the end of March, forgot to make a video about this, but apparently the Milky Way galaxy, and I was right when I said this in the past, is actually a lot bigger than we previously thought. Before I made a video saying it was like around 256,000 light years in diameter. Well, it turns out now it's 1.9 million in diameter, the total light years it is. And so if you think about it, one astronomical unit is 93 million miles from here to the sun. And what's really interesting about that is our solar system is 122 astronomical units, but one light year is 63,241.1. It's really 0.077 is more accurate, but just rounded up a little bit. And that's basically how many astronomical units are in one light year. So you would times that by 1.9 million and whatever 63,241.1, and you get that answer, divide that by 122, would be how many times our galaxy, or how much bigger our galaxy is than our solar system if you were just to line it up all the way across. And I think that's really interesting to think, because it really got me thinking. You know, the biggest galaxy that I could find that we know of on the internet is IC space 1101. And they said, right, if the Milky Way galaxy was like 100,000, which was on the small side of what they estimated, it was basically like, before they revised it, it was like supposed to be like at least 60 times bigger than the Milky Way galaxy. And it's really interesting because if you're someone who studies, like, you know, distance and all that from you, like you take a telescope, like a really big one, and you can observe like light years ahead based on the zoom in ratio and the diameters that they can pull off based on those statistics. It's really interesting to think that if our galaxy is truly that much bigger, and there were galaxies out there that were without a doubt even bigger than our galaxy, does that mean that that size ratio still stays the same? Because what's really interesting is they say that our galaxy has at least 1.5 trillion stars in it, but at the same time, or at least the mass of it anyways, if that's what they mean by that. And so, does that mean that for every other, you know, galaxy that's significantly bigger than ours has even more stars in it and the mass is higher, because the bigger the ratio, the more. But what I think is really cool is, you know, that galaxy has 150 trillion stars, or at least the star mass at least. And it just really, you gotta really think, like, there's just so much out there we don't know, let alone things that are lost in time and space. And, you know, it really makes you wonder, like, how is it that something so big, like, how can they even measure something like that accurately? And I mean, because I'm not a scientist in that, I'm more of a translator. But I've always found this stuff fascinating because, you know, there's so much out there we don't know, and yet we're so arrogant to, you know, it's fascinating. Like, some people, like, don't want to believe this, but it's true. There's so much out there we don't know, and yet the answers are just waiting to be discovered, and it's fantastic, because I can see why scientists really do love what they do for a living, because of this kind of achievement and accomplishment. It really gives life a meaningful event.